Okay, so for you who are probably wondering why differentiation is actually related to tangent line, then why do we do it that way? So this is one of the explanation. So if let's say we have this green curve, it's a y equals x squared plus 3x curve. Based on the previous video, I made it like in such a way that you see there's this tangent line at x equals 0, then by the graph, it should be y equals 3x. But then how do we know that it should be y equals to 3x? So then let's say, so by the procedure that we have, we know that y is x squared plus 3x. Whenever we want to know the gradient, then we derive it, right? So when we derive it, so if you see the idea before, it's actually like a gradient. So then that's why whenever the point are here, so then we try to make the two lines, and then it keeps on getting closer and closer. So the tangent line keeps on getting closer and closer. So we should have noticed that the actual meaning is the way we actually look for is actually the gradient. So then the gradient of this line and the gradient of this line, as the 2 points are getting closer, the B and A are getting closer. So then they meet at one point. So then it becomes the tangent line of the curve at exactly that point. Okay, so but then the idea is that's a gradient, and then the gradient is getting smaller and smaller. Not smaller in the sense that the gap between the 2 points are getting smaller and smaller. That's why you see from the previous video, it goes like whenever it goes smaller, the changes becomes very small between the 2 points, then it becomes a gradient of a tangent line. So then the idea of getting smaller for the changes, actually it's the same like gradient. The gradient is, the way you call it, is delta y over delta x, which means the rise over run, right? But then as the delta x goes very small, the delta y also goes very small. It should make sense, right? Like because we have the 2 points previously, the 2 points are one here and then one here. First, the gradient is like this, so steep, right? But then as we go closer, let's say the point is now moved to, let's say, here, then it goes like this. So then the gradient keeps on changing. So the delta x and the delta y, they keeps on being different, so they keeps on changing. But then at certain point, when the delta x goes to 0, then we call it as the concept of limit. The ratio or the gradient, then we call it as dy dx, because it's like so small. Then rather than writing the limit delta x close to 0, then let's make it another symbol. That's the mathematicians. That's what they do. They often make another symbol to simplify the words or statements. So now we have dy dx. But what does the dy dx represent? It's the tangent line. It's a gradient. Once again, it goes back to the gradient. But then the idea is actually coming from here. So then now how do we know that the gradient on that particular curve, it should be like this? Okay, so then because the idea of let me move on, because the dy dx itself is about limit delta x close to 0 of the delta y over delta x. Now what it means like by this is, for example, delta y means the vertical, right? So then let's say I change the language for you. The function before is x squared plus 3x. Let's say I name it, rather than using delta because it might be confusing, let's just use h. So then let's say fx, this is fx. So then I could have like fx plus h. The h is representing the difference. So limit h goes to 0, so it means h is equal to delta x. So it means like f of x plus h minus fx over x plus h minus x. Does this make sense? So the upper part representing the delta y, the bottom part representing this. Delta y means difference between y. So fx plus h minus fx. If you see like the like the curve like this, it goes like, for example, here and here. So you make this. So it's like this is the fx plus h. This is fx. This is the x plus h. this is x. So then it goes like kind of like that. So then if we make it into the context of the function, so then it should be like limit h goes to 0. Let me change the color. So then it goes like x plus h squared plus 3 x plus h minus x squared plus 3x. I just plug in all the numbers, the function, and over, because this will be just h, right? Because x is gone. So this is what we have. So basically what we are doing with the differentiation is calculating the gradient. Now because it looks so complicated like this, actually we can just simplify, just like normal simplification. This is what I mentioned in the class, that it's so unfortunate actually that we don't learn about what the concept of limit. Well, that's actually one of the most important thing that we need to learn in calculus, or differentiation and integration like this. So you see there are a couple of things that we can omit. This we can just remove. This we can remove. So then we are left with the 2hx plus h squared plus 3h, which is, if we simplify, we should be getting 2x plus h plus 3. So if when the h is very close to 0, then this will be gone. So then in the end, we should be getting 2x plus 3. And if you notice, this 2x plus 3 is actually just the differentiation of this. That's where the gradient comes from later on after this. But that's roughly the idea of differentiation.